will take computer, estimate the model, and will make the predictions. First, we will show you how to do it theoretically, and then we will discuss this by using computers. We will go into the details of this. Basically, as I have said, you can have ARMA 1, and you can have ARMA PQ. P could be any number, Q could be any number. We have to decide between these. So there are different methods of making these choices, and we will discuss how to choose between ARMA models. I have said we will go into the details of this, how to determine legs, how many legs to be included in the model. We will go into the details of this. But before that, what I want to discuss right now is how to make the predictions and how to estimate these models. Basically, how to estimate ARMA models, let me discuss this first. How to estimate ARMA. If I split this into AR and MA separately, I am discussing the AR first. Suppose you have this data 1960 and then 1961, 1962, and so on. And there are observations. This is Y1, Y2, Y3, up to so on. So this is your current variable yt. How to make yt minus 1? If you actually write for 1961, what happened in 1960 is the lag term, is the past observation. So this observation should come here, right? And in similar way, here you will have y2 and so on. Now, if you have data like this, you can run auto-regressive model by using your, even you can run this regression in Excel. Okay. I will actually show how to run this regression. This is very simple. This will just OLS regression in which you will design the legs in this way. See. On the other hand, there is MA model. Okay. What is MA model? MA model is a model like this. Yt is equal to theta epsilon t minus 1 plus epsilon t. The past shock and the present shock. What you will have actually, you will have a series like this. Y1, Y2, up to so on, Yt. You will not have any epsilons here. In the data, you will find only y's, but there will be no epsilon. So how to estimate this model? Basically, this is iterative process. One time you assume one value of epsilon, and using this you predict epsilon 2. Then using epsilon 2 you will predict epsilon 3, and so on. and then there will be iteration. First time what you found as epsilon 1 would be used in the second analysis, and the process will be repeated. It will be iterative process, and it takes a long time. Basically, this is called numerical estimation. This is a tricky job, and you cannot do it manually. There are automatic built-in mechanisms in the softwares like EViews. EViews will do it for you. There is a long mechanism behind all these things, but if you want to do it manually, you cannot do. This will be done by computer automatically. So anyway.
Is it better to estimate just a autologous process and estimate the error? So we have the MA series. There is no need to iterate the procedure again and again. So just try to find out the errors by running the autologous regression. So you can make any.
If you are estimating the errors from autoregressive process, actually it was a MA process, the estimate of epsilon would be different from what you get from purely MA process, right? As assumption based on the autoregressive process would be somewhat different from what is happening actually.
Sir, as you know that this process YT, suppose YT is equal to YT minus 1 plus epsilon. So it means epsilon is a part of YT.
Right.
So again, if we include the lag value of epsilon t minus 1, again it is the part of YT. So basically both errors are the part of YT. So why we are getting it again and again by iterative process? Why we are not using a simple trick to run the autologous?
So YT is some term like 80, right? How much of it should be error term? Okay. If you just have autoregressive process, this is very simple to calculate, right? But if you have MA process, what was the past error? That will determine the current error, and that becomes a tricky job. For example, your current state of variable is 80, and the past state of variable is 76. Now this 4 is the differential. This differential is theta epsilon t minus 1 plus epsilon t. How much should go into this and how much should go into this? Okay. This is somewhat tricky job. It is basically, there are built-in algorithms in the software which can do it for you, but if you want to do it manually, it is difficult. Okay, so now I will tell you how to make predictions on the basis of this.
Sir, this ARMA model is good to predict without having another variable?
It sometimes outperforms some of the theoretical models, but there is nothing guaranteed. Sometimes it gives you very good predictions. Actually, what is happening is in uncertainty. You don't know this time I'm hitting the correct format or not. This is a problem. But sometimes really it gives you very good results. Anyway, suppose you have made a model like this: yt is equal to rho yt minus 1 plus, let me, I think I should go on the selection of ARMA model before we go on predictions, because this is something people are more interested in. So, how to select ARMA model? Basically, I have said you can have this model yt equal rho yt minus 1 plus theta epsilon t minus 1 plus epsilon t. This is ARMA 1, and you can have very large model like this, ARMA PQ, where P is equal to 2 and Q is equal to 3, or a reverse of this. Yeah, you can have 4 and 5 instead of 2 and 3. You can have 10 and 20 instead of 2 and 3. So what is the most appropriate leg order to include in this model? Basically, there are 3 approaches. There are 3 approaches to decide the leg length. What are the 3 approaches? First approach is based on information criteria. What is information criteria? We don't need to go into the details of this, but when you estimate a model by using some econometric software, one of the output is the information criteria, right? What happens, you can have different combination of AR term and MA terms, and the combination which gives you minimum value of AIC should be selected, right? Suppose you have AR orders. Here is AR order. Here is MA order. The AR order may start from 0, 1, 2, 3, and similar